This huge building you see behind me is one of Ontario Power Generation's nuclear power generating stations. In essence, it's a factory that converts the energy of the atom into a flow of electrons, or what's commonly called electricity, the electricity that helps power the province. Nuclear, hydroelectric, and fossil fuel generating stations have many similarities in the way they generate electricity. Where they differ is their fuel source. OPG's nuclear stations use naturally occurring uranium that's processed into little ceramic pellets like this. An unused fuel pellet emits very little radiation. However, it holds the potential to produce a whole lot of energy. Just 8 of these pellets will power an average house for almost 1 year. The fuel pellets are sealed into metal tubes, which are then welded together to form a fuel bundle. Several thousand fuel bundles are then inserted into a large tank called a calandria, which is the heart of the nuclear reactor. Nuclear generating stations split the uranium atoms in the fuel in a process called fission, and the result is the release of a tremendous amount of heat. To unlock the heat energy in the uranium atoms, you need what's called a moderator. In CANDU reactors, a special kind of water called heavy water is used as the moderator. Heavy water is 10% heavier than ordinary water because it contains a higher than normal proportion of deuterium, which is a form of hydrogen. The heavy water surrounds the fuel bundles and slows down tiny particles called neutrons, so they are more likely to hit and split the uranium atoms. A chain reaction of atoms splitting ensures there is a constant source of heat to heat the heavy water. The heated heavy water is pumped through the reactor in a closed system to a set of boilers, where it boils ordinary water into high-pressure steam. The heavy water, having done its job, is recirculated back to the reactor to pick up more heat and cool the fuel. The high-pressure steam, made from ordinary water, is transported through pipes to a large turbine, where it pushes the blades and turns the shaft connected to a rotor in the generator, causing the rotor to spin. The spinning rotor is a large electromagnet that produces a rotating magnetic field. This field moves across coils of copper wire in the generator stator, producing electricity that can be sent across transmission lines. The steam coming out of the turbine is condensed back into water using cooling water from the lake and pumped back to the boilers to continue the process. Ontario Power Generation's nuclear generating stations have sophisticated safety systems to control, cool, and contain the process each step of the way, generating electricity safely and virtually free of all smog and greenhouse gas emissions.